In this question, we have to find out the unit of electrical energy in terms of fundamental SI unit. Although there are various forms of energies, mechanical, all types of mechanical energy, thermal energy, sound, electrical, and like all the forms of energies have the same unit, that is joule. And you can express joules in the terms of fundamental SI unit, but in this question, we will find out first of all the joule in terms of fundamental from its specific circuit. Okay, so because they have mentioned here electrical energy. So, what is the electrical energy provided to this circuit? So, this is the current, a conventional current flowing to the circuit. So, what is the total power delivered to the circuit? Is the power is equals to the current multiplied by the EMF of a circuit. Okay, you can use a simple equation W is equals to Fs cos theta to find out a unit of energy in terms of fundamental SI unit, but we will take specific this circuit and its equation to find the final answer, right? So power is equals to the energy delivered to the circuit per unit time. So if you want to find out the energy, you have to multiply the power multiplied by the time. Since the power equation for the electrical circuit is I multiplied by the EMF multiplied by the time, so we will try to find out the unit from this equation, right? Now, in terms of units, the unit of current is ampere multiplied by the EMF, or the potential difference, have a unit joule per coulomb, because if you remember, the potential difference can also be written as the work done per unit charge. So from here, the voltage, the volts is equals to the joule per coulomb multiplied by the unit of the time is second. Now the coulomb, the quantity coulomb is a derived quantity, okay? And the coulomb is equals to the ampere second, because the charge is equals to the current multiplied by the time taken. So that's why you can put the value, I mean the coulomb can be written as ampere second multiplied by the second. So this is cancelled out, and now we have just left joule, which I already told you that the unit of energy is joule, but it's good that we have seen it from another equation. Now the joule is equals to the Newton times meter, okay? And the Newton is a unit of force, and the force is equals to the ma according to Newton's second law, right? So that's why the Newton should be equals to kilogram meter per second square times meter. So hence this is the fundamental SI unit of energy, which in which all the units are the fundamental SI units.